Hello everyone, my name is Ali Berke Akçay. I'm a first year electrical and electronics engineering student at Bilkent University. Today, I will present you my lab project experiment for the Physics 102 course. The objective of my experiment is to observe the magnetic field created by a circular current loop along its central z-axis and to confirm its proportionality relations with the distance, the number of turns, and the coil radius. With this experiment, we can also extract the vacuum permeability constant and compare it to its real value. Now we will derive the necessary formulas for this experiment. We start with the general form of the Biot-Savart law. Because of the symmetry of our circular loop, the perpendicular components of the magnetic field cancel out. By integrating over the circle, the steps are as the following to get the equation for the magnetic field along the z-axis. Additionally, in order to calculate the vacuum permeability constant more easily, we will linearize this formula. This gives us a linear relation between the magnetic field to the power of negative 2/3 and the square of the distance. By plotting this, we can calculate our constant from the slope of the best fit line. Now that we got all the necessary formulas, let's move on with the procedure. The equipment used in this experiment were the following: short copper coils, a non-magnetic wooden ruler, a DC power supply, a resistor, a multimeter, and a smartphone with the Pi Focus app. Also, we used a small reference magnet. I used the small reference magnet to pinpoint the exact location of the smartphone's sensor chip. With the power supply turned off, I measured the baseline magnetic field of the Earth. Then, applying a steady 0.1 ampere current, we started our measurements from the center, incrementing the distance by 3 centimeters each time. Each motion was repeated 5 times for each coil. Now moving on to the results. You can see the measurements of our magnetic fields and their respective data. After we were done with the measurements, we calculated the error percentage. Here are some graphs generated with Python to better visualize our results from this experiment. Firstly, we can clearly observe that our experiment confirms the proportionality relations between the distance, the number of turns, and the coil radius, giving us incredibly high correlation coefficients of very close to 1. Secondly, we calculated our average experimental vacuum permeability constant to be approximately 1.58 times 10 to the minus 6 Tesla meters per ampere. The error between our experimental and theoretical constants were 26.2%. Now I would like to discuss some potential causes for this error. Firstly, our formula was an approximation formula. Therefore, it assumed a perfectly short coil, ignoring its thickness. However, our coils had a non-negligible thickness, which created an error especially visible at the closer distances. Secondly, detecting the exact center of the smartphone sensor with tape was challenging, meaning the sensor might not have been perfectly aligned with the center. Thirdly, the background magnetic field of the Earth was fluctuating constantly because other students were conducting experiments with currents nearby. Additionally, the reading on the smartphone was constantly fluctuating, which forced us to eye-pick the center of oscillation, creating a ±1 microtesla uncertainty. Lastly, due to equipment and time constraints, the wooden ruler was held by hand instead of being firmly mounted, which created a great potential for personal alignment error. That was my Physics 102 lab project with its theory, data, conclusion, and error discussion. Thank you all for watching.